Hey everyone, welcome to today's High Speed Explainer. We are going on a rapid fire journey today through some of the absolute latest AI breakthroughs that are, without a doubt, going to challenge your very understanding of reality. We're talking about innovations bridging the gap between human biology and artificial intelligence in ways that honestly sound like pure science fiction, but they are happening right now. In fact, let's start with a scenario that sounds completely impossible. Picture this for a second. You're just chilling in a chair, looking at a robotic arm across the room, and you move it to grab a physical object in the real world using absolutely nothing but your thoughts. No controllers, no voice commands, literally just the electrical signals of your own mind dictating the movement. Pretty wild, right? But what if you wanted to communicate rather than just move? Consider this one. Imagine carrying on a fluid, deeply expressive conversation, speaking completely clearly to the person sitting next to you without your vocal cords making a single sound. We're talking silent communication, brought to life entirely by algorithms interpreting your body's hidden signals. Sounds crazy? Well, it gets even deeper than that. Here is the ultimate existential hook. Can your mind, your unique, specific way of reasoning and thinking, live inside an AI long after you are gone? By the end of this explainer, we are going to answer this exact question. We'll look at how a lifetime of knowledge is actually being transformed into digital twins. But before we get to your digital soul, we have to start with the physical body. Okay, let's dive into this. Section 1. The physical hook, where AI meets the human body. Let's look at some immediate, visceral medical applications. This is where artificial intelligence directly interfaces with our biology to restore what we previously thought was permanently lost. What if AI could completely bypass a paralyzed spine? This isn't just theory anymore. A groundbreaking implant, paired with AI, recently helped a paralyzed man regain both hand movement and physical sensation. It is an absolute medical marvel that fundamentally changes how we view spinal injuries. But how does this actually work? Researchers are calling this a double neural bypass. It's kind of like a biological detour. Step 1, the system decodes the patient's intention to move. Step 2, it sends those commands directly to stimulators connected to his muscles. And then step 3, sensors return actual touch information back to his brain, entirely bypassing the damaged spinal pathway in both directions. Now, to be clear, current chips can't just download your memories or anything like that, but they absolutely can decode these limited, specific patterns of intention. So if we can decode movement, what else can we detect? Well, a neurotech company called Hemispheric is developing an AI system that analyzes electrical signals from a standard EEG headset. They're training their model on thousands of hours of brain data, aiming for a quick 15-minute test that could actually help doctors identify patterns connected with neurological or mental health conditions. It's still in development for sure, but it shows just how accessible this kind of tech might become. But detecting patterns is one thing. Acting on them is a whole different ballgame. Let's see how these brain signals translate into external action. BrainCode demonstrated an AI system using an EEG headset that detects specific neural patterns and translates them directly into robotic action. In this stunning demo, a user literally just thought about an action and a robotic arm reached out and grabbed an apple. The AI interpreted the intended command in under 200 milliseconds. That is blazing fast. So what if we applied that kind of speed to human speech? Taking this a step further, can you speak without using your voice at all? Researchers have created an AI-powered wearable device that sits right on your throat. It detects tiny muscle vibrations and pulse signals. The AI then interprets those completely silent signals and converts them into fluent, emotionally expressive speech. While it definitely still needs larger clinical studies, this could one day totally revolutionize communication for anyone with serious speech impairments. But to pull off all these real-time biological miracles, the AI needs a massive engine upgrade. Which brings us to Section 2, the hardware hook, supercharging the AI engine. All of these incredible physical applications require immense computational power. So how powerful could AI actually become if it had 4 times the memory density? AI is getting incredibly smart, but its physical memory hardware often struggles to keep up the pace. Recently, researchers in South Korea developed a highly experimental method to stack more than 10 ultra-thin memory chips on top of each other using low temperature and pressure, and this brilliantly illustrates the leap we're talking about. To put it into perspective, each of these chips is roughly 1/5 the thickness of a human hair. By stacking them so efficiently, they can produce about 4 times the integration density of current high-bandwidth memory. If this actually commercializes, future AI devices aren't just going to be smarter, they're going to be massively smaller, insanely fast, and way more energy efficient. And with that kind of power, we can start tackling the world's biggest physical mysteries. With this kind of hardware evolution, the applications just scale up dramatically. Could 3 totally different types of computers working together finally help us unlock fusion energy? See, one of fusion's biggest hurdles isn't just making the energy, it's securing enough of the incredibly rare fuel needed to sustain it. To tackle this, researchers from IBM and Oak Ridge teamed up. They combined AI, quantum computing, and conventional supercomputers. And the result of all that computing firepower came down to one magic number: 9. That's the crucial point here. Using this tricomputer alliance, they calculated exactly 9 specific molecular configurations of a molten salt called Phlebe. This salt could actually help future reactors produce and recover that rare tritium fuel. Now, this doesn't mean we're flipping a switch on fusion tomorrow, but it absolutely proves that AI, when supercharged by quantum hardware, can solve calculations that were historically impossible. So we have the physical tools and we have the hardware. Now, what happens when we aim all of this directly at the human mind? Let's move to Section 3, the existential hook, creating your digital twin. We are crossing a major threshold here, moving from biological tools straight into digital identity. Can an AI actually preserve the way a human thinks? Imagine leaving behind not just your money or your written words, but your specific reasoning style for future generations to interact with. Ray Kurzweil and Praxis AI have introduced an innovation that aims to do exactly that, promising to preserve a person's entire intellectual framework. They are calling this RAI, which the developers describe as a human-first digital twin. Here is the kicker. When you ask this AI a brand new question, it doesn't just pull some generic answer off Wikipedia. It generates an answer specifically intended to resemble the original person's unique reasoning style and logic. But how on earth could a machine possibly know how you, specifically, think? Well, here is how they actually do it. The AI is fed a lifetime of your accumulated knowledge. We're talking about all of a person's published books, their interviews, lectures, past decisions, and recorded explanations. The AI model absorbs all of this and learns the deep underlying patterns and how that specific individual approaches questions and communicates. The result is an interactive educational assistant that sounds remarkably like them. It sounds a whole lot like digital immortality, right? Well, actually, not quite. We need to pause for Section 4, the ultimate reality check: simulation versus consciousness. We have to be really clear here. Does this mean we are actually achieving digital immortality? The reality is no. This technology does not prove that an AI contains someone's actual consciousness, real memories, or a living mind. It is simply producing responses using massive amounts of data and learned patterns. And here is the absolutely critical limitation. Even when the answer sounds perfectly convincing, the AI might generate a statement or an opinion that the original person would never, ever have actually said. The strongest claims right now are coming from the developers themselves, so this absolutely requires independent evaluation. And frankly, this limitation opens the door to a terrifying question. If we build these hyper-convincing digital twins, who actually owns your digital identity after you are gone? Who controls the AI system? Could a bad actor manipulate your digital twin into promoting ideas or even products that you, the original human, never supported? We are seriously blurring the boundary between an authentic human legacy and an AI-generated imitation, which leaves us with one final thought to chew on. Today's digital twins are definitely not immortal human minds. They are highly advanced simulations built from our data. But as these simulations become incredibly, seamlessly convincing, figuring out exactly where the real person ends and the AI begins is going to be one of the greatest challenges of our future. Knowing all of this, the medical breakthroughs we just talked about, the massive hardware scaling, and the deep ethical dilemmas, I will leave you with this. Would you create an AI